Hi, my name is Nick Stroh, Chief Architect with ICG. So welcome to a high-level overview and demonstration of the new version of LUX, which is version 2.8. And LUX is our real-time data exploitation platform. So I'm going to briefly go over a couple of high-level slides and then jump onto a LUX system and do a live demonstration of the major features. LUX enables users to understand and take advantage of large volumes of streaming data. They can identify entities of interest, they can find patterns and trends using our built-in analytics, and they can even start to predict future activity. Looking at the diagram, on the left are real-time data streams coming in from a variety of sources, likely in a variety of formats, and they flow into LUX, which performs a number of processing and analytic techniques on the data and presents the results to the analyst through several dashboards. And the analyst is interacting with the dashboards rather than just observing them. So they're actively writing rules to interrogate the data streams and getting rapid feedback so they can iterate on and fine-tune their search. LUX is software that can handle billions of events per day on commodity hardware, so the more sources you give it, the better. Each new data source is just going to enable the analyst to gain more insight into the situations they're observing. This is the architecture of the LUX data processing pipeline. I just wanted to show this slide quickly so that the terms I use when I'm demonstrating the tool make sense. Data is brought into LUX through the ingest component, which is the first step in the pipeline. You'll notice there are these plug icons in the ingest and a few other components. And this is to show that LUX is a plugin framework. So LUX is a tool that is used in many different production environments across a wide spectrum of industries. So using a plugin architecture has allowed us to adapt the tool to a particular customer's needs without having to write any new code. Ingest plugins fetch data from real-time streaming sources and bring them into the LUX pipeline. Enrichment plugins add metadata to the events that add context to make an analyst's job easier. An example of an enrichment plugin is, let's say we find an IP address in an event, we can do a geo lookup and add country, city, state, and zip code attributes as metadata onto the event. And this lets analysts write rules like show me all the network traffic in Minneapolis. And that's a type of rule that would be very hard to write against the raw data stream without these enrichments. Analytic plugins look for more complex correlations in the data that would be hard for an analyst to define through a user interface. Examples of analytics would be looking for abnormal tracks or statistical deviations from historical levels of activity, or finding entities that are behaving certain ways. So here's an example. We're going to look for entities that are co-traveling. So we have two entities, entity A and entity B, seen in location 1 together. And then if we continue to see them in the same locations over time, we'll produce an analytic event, and in this case, a co-traveling event, which would include entities A and B and the 3 locations, and then we can write rules on top of that. So then the analytic data feeds and the enriched data feeds all flow into the matching component. In the matching component, the data streams are matched against analyst inquiries, which we call rules. And when the rule criteria matches against an event, an alert is created. And the alerting component can send alerts out to different sources, also in different formats, and then they're sent back to the analyst through the LUX dashboards in near real time for review. So with that overview, let's jump into the live tool. This is the LUX user interface. It's what analysts use on a daily basis to accomplish their objectives. This is where they create and tune their rules, view the results of those rules via alerts, and collaborate with their fellow users. This is one of our demo systems, and we have dozens of data sources flowing for example purposes. But a few we're going to use today are MTT, which is boats on the water, OpenSky FAA data, which is commercial flights, and RSS News, which are news articles. So why don't we jump right in and create an OpenSky rule. I'm in the Maryland area right now, so I'll create an area of interest, or AOI, around Maryland. Now I'll create a rule, and to do that, I'll choose a rule template. We have a lot on this system because there are a lot of data sources flowing through here, but what we want is the Open Sky rule template. We'll give the rule a name, and the only rule criteria we'll use is to say that the data has to be inside of that new area of interest we created. Now you'll see that that new rule appears in the column on the left called the rule tree. And this shows all of the rules for this particular project. Projects are a way to organize rule sets so that they make sense for your business. Projects can be private to one user, but more often they are a collaborative space for teams to work collectively toward a goal. So everyone in this example project can see and interact with this rule set. The middle panel is the alert display, and we have 5 options controlled by these 5 buttons for which display to use. Now, selecting the checkboxes next to the rules in the rule tree controls which alerts that you'll see in your chosen alert display at a given time. Now, it's important to understand that the rules are running at all times, and we're just selecting which alerts to view. So let's select our new rule. And if we select one of the alerts from our new rule, we'll get the details of that alert. So this shows all the attributes in the original event, as well as any metadata that the enrichments in the LUX processing pipeline that you'll remember from the architecture diagram have added to the event, such as this nearest airport and registry data information. So this will allow an analyst to easily filter their rule for distance from the nearest airport, for example, or planes of a certain engine type. If we switch over to the alert list view, we'll see all of the alerts in temporal order. And we can enable multiple rules to see how they all occurred over time in comparison to one another. And we can easily see what our newest alerts are. And if we switch over to the timeline view, this is another temporal view of our data, and we can look for maybe correlations that we didn't know about, how these two rules seem to always fire around the same time. Maybe there's some correlation here that we weren't otherwise aware of. This is the chart view, and this will show us any statistical anomalies, spikes over time. Then there's also the baseball card view, which is a good way to consume things like articles because it lets you read a quick summary and you can kind of quickly scan and consume a lot of content. Now all of these different alert displays respect the time slider, which is this bar at the top here. So if we take a look at this basic rule, JetBlue over New York City, this is saying call sign starts with JBU. That's going to find JetBlue airplanes on the ground as false. So this is going to find JetBlue airplanes in the air and inside of our New York City area of interest. So you can imagine there's going to be quite a few planes here if we have our time slider set to 1 day. There's 1,200 hits here. So if we turn that on, we get quite a few alerts. But if we change the time slider to say, okay, only show me the last 15 minutes, it's a lot less data. And so this will also carry over to the alert list view. And these are only those alerts that fit within the last 15 minutes. This is as far back as it goes. And it doesn't have to be up till now. So we can switch to 1 day, but it doesn't have to be today. We can just slide it back. And now we're looking at yesterday. So a couple of other examples of kind of pre-cooked rules that we have here to give you an idea of the types of things that you can do with LUX, but by no means an exhaustive overview. Here's a rule, RSS English Trump, and this is running on the RSS data feed, so this is running against news articles. It's looking for detected language equals English, And detected language comes from an enrichment that we have that looks for the main language in an article and adds it as a property. The next criteria that it's looking for is main person contains Trump. Main person is also not something that's found in the raw event. We have a natural language processing enrichment that will tell us who it thinks the main person of the article is. And so we're looking for Trump there. So if we look at the results from that rule, here's an article and it looks like it's about President Trump. Then, as we mentioned, we have analytics running in the pipeline, and analytics are producing their own event streams. So MTT loitering is a rule that is simply looking for all of the output from the loitering analytic. And so if we see what that looks like, we can switch over to the map view. And what this is going to find is it's going to find every loitering vessel in the world, every loitering vessel in our data stream. And so loitering as defined in our analytic configuration, it's, a certain amount of distance traveled in a certain amount of time, looking for boats that aren't really moving. And so we get all of the loitering vessels. But what we can also do with the output of our analytics is we can write rules on top of them. So MTT loitering in the Chesapeake Bay is taking the output from that analytic, but then putting extra filters on top of it. In this case, it's just a geospatial filter that says, okay, I don't care about loitering vessels in the world. I care about only vessels that are loitering in the Chesapeake Bay. And so these are some of the results from that rule. Time correlated rules are another type of more advanced rule. And so this rule set here is all working together. Time correlated rules you can think of as rules on top of rules, and they let you do more advanced things. As analysts get to know the system better, they want to write more and more powerful rules. So we have here a few basic rules, like planes entering 40 kilometers around DC. This is saying, show me one alert for each distinct plane as identified by call sign inside of, well, tell me when it enters a ring around Washington, D.C. of 40 kilometers that we drew. And so if we turn on the alerts from that rule, we see lots of planes entering that 40-kilometer ring. But if our objective was to determine if a plane is actually approaching Washington, D.C., this wouldn't be enough, because you see a lot of these planes are running these tangent tracks heading off to other destinations. And so what we can do is we can do concentric rings approaching DC, and then we can write a time correlated rule that leverages all three of those rules together. And so with this we can say, when we have at least 3 alerts from 40 followed by 30 followed by 20 within an hour in that order on a common call sign, now we know we have a plane that's running that approach pattern that we're looking for. And so if we select those results, we get planes that we can say are actually approaching DC because they've passed through all of those rings in order. And similarly, if we just reverse the order of that rule, we would get planes departing DC. Another thing I want to point out is that analytics do produce event streams, but they can also help and create overlays for the map. So here is an open sky heat map. And what these types of analytics do is they really just provide a window into the data stream, because a lot of times analysts have no idea what the data looks like or what's in the data feed or where to start. So this is a visual overlay of where the most of the data is located. And, maybe this hotspot right here isn't something that they would have expected. And so they want to go ahead and start writing rules in that area to see what's there. You're not going to hurt LUX by writing rules or writing too many rules or too broad rules. There are circuit breakers in place to protect the system. Another component to discuss is the entity manager. So the entity manager is running in the background at all times and tracking entities through all of the data streams. So it's identifying them, it's updating them, it's correlating them, all in near real time. And so one of the features that this enables is a common operational picture layer on them. And this will give us additional context to our alerts. So sometimes a push pin on the map by itself doesn't tell us too much. So the entity manager allows us to turn on these configurable layers and say, well, what else is happening around here right now? And similar to a rule, we can display all entities. So here we're looking at, these are all planes right now, or we can filter down to specific subcategories, right? Maybe we just want to look at the JetBlue planes, so we could create that layer. And once we've set those criteria for our layer configuration, we can test it to make sure that it looks like what we're expecting, and all these call signs start with JBU, so this looks correct. And we'll save that, and it's immediately active, and it will immediately tell us what we want to know, which is where all the JetBlue planes are. And if we click on an entity, or if we see an entity linked from one of our alerts, we get some extra context that we wouldn't have necessarily found otherwise. These are attributes that were aggregated as they were seen in the data feed. This is a long historical track for that entity. And we also can do relationship diagrams based on analytics. So you can imagine if we have, say, that co-traveling analytic that we discussed earlier, we could have that automatically populating an entity relationship diagram in the background and showing us, say, all the planes that were co-traveling together. So this is a brief walkthrough, but there are many other features, and especially more advanced features within LUX that we'll cover in future videos. Now that we've gone over the major features of the user interface, here are a few quick facts about the LUX platform. LUX is a stable and operationally ready platform. It's proven itself in mission-critical environments for many years. LUX has processed over 6 billion events per day in a production environment. And this was achieved on a single rack-mounted server while executing a customer's full rule and analytic workflow. LUX typically runs on enterprise rack-mounted servers, but the LUX engine also runs on edge computing platforms, including single-board computers that'll fit in the palm of your hand. I just want to mention the plugin architecture again. A LUX license comes with over 100 plugins that we've developed over the years in our work with dozens of customers. And it also includes updates, so as we develop new plugins, you'll get them as well. If you have developers that you'd like to make your own plugins, we have an API and a plugin development kit to support that come with LUX. And of course, any plugins that you develop that you want to keep internal to your organization, you can. In the demo, you saw the variety of different ways that LUX can present your alerts to you. Now, we touched a little bit on the entity capabilities in the user interface demo, but it's actually a very rich subsystem with entity relationship diagrams and automatic relationship discovery via analytics. We'll do a deep dive into these capabilities in a future video. That wraps up our LUX overview. Thanks so much for watching. If you have any questions, please shoot us an email at info@icgsolutions.com, and you can reference this video OV1. Thank you.